Hello, my name is Anna, and as I am learning Luxembourgish language, ich heiße Danna. Today we are going to talk about issues related to asynchronous interaction between client and server or between servers. As for me, I work in the company Artec3D. I'm a team leader, I'm a backend developer, and I like playing with other languages because it can be interesting. Last language that I was trying to learn is C#, and actually there are a lot of things there that I miss in Ruby. For example, methods overloading or interfaces. In our company, Artec3D, every backend developer is responsible for a part of our infrastructure because we don't have DevOps or SRE engineers. It can be tricky because when you are talking about, when you are responsible about server infrastructure, you can't just be just developer. You have to have other skills from different area. I suppose it can be two or three different. It should be 2 or 3 different persons, but in our reality, it's only our backend team. But it has great benefits because you can think about a feature not just on the code level, but on the infrastructure level too. 6 years ago, we started a project called ViewShape. It's a 3D scanning related project which is made for our clients to be able to upload their 3D models and so to share it, to rotate it. And this is Stoned Fox. Several years ago, we hosted on EuRuKo. We had one dyno for free, and we were happy with our small application and not many clients. But then we scanned this Stoned Fox while its creator, Adele Morse, was in Russia, and a lot of news agencies posted news about this model because it was quite popular meme back at the time. And we were down. We were totally down because we were not ready for this capacity. We started to raise lots of dinos, and we still were down for several days. After that, we received a bill in the end of the month, and then we thought, oh, hey, we must do something with our infrastructure. So guys, I want to ask you, have you ever had downtime last year? Oh my God, guys, I love you. Okay, last month, last week. Okay, cool, not me. Last week I didn't have a downtime. Yeah. Did you say you have a downtime right now? Cool. I think downtimes are okay because you never know what kind of capacity will you get. And sometimes you may have your capacity may grow in unpredictable way.
So let's talk about interaction patterns
and how they can help you to avoid downtimes. Let's talk about it in the perspective of requests. So when a small application starts, it often begins with synchronous request and reply. A little bit after, it can evolve and has some asynchronous interaction. But there are a lot of patterns that are more wide than these two terms. For example, asynchronous interaction with timeout. When your application receives, when the client sends the request to a server, then it waits for some time. It receives a response or timer or timeout arrives. So, but after timeout, application doesn't wait for response. It can be quite useful when you need to do your to implement part of your feature that has its time limits. For example, when you're trying to order a flight, to book a flight, you need to receive information about available flights in 30 seconds, because after a minute, 2 minutes, 3 minutes, it can't be not relevant anymore. The next pattern is asynchronous request reply with a notification timer. It also can be useful. For example, your client send the request, your server process this request, and then on the client it started a timer. And the client waits until timer expired, or until a request or reply arrives. So whatever comes first. Another one is one request and multiple response. Mandatory response and optional response. Your client sends the request to server, then it receives a response synchronously, and then it can receive several notifications or several responses in a synchronous way. For example, you are ordering something, and you create an order, and then server checks if it is available, or you should wait some time. So your order is created, but then you can receive some valuable information. Another one is one request, mandatory response, and optional response. It's quite the same. Your client send the request and gain mandatory response, and after it can receive other information. There is another one pattern is called unsolicited notification. It is when your client doesn't wait for anything and then receives updates. For example, everybody who uses bank applications receives information about, oh, hey, credit is available for you, so you can do this or do that. Yeah. So let's go back for 20-25 years when requests were synchronous, a little bit asynchronous, and it often says that scaling up is failing up. So back in the time, most applications were monolithic, and the only option they had is to buy biggest hardware. But when you are planning to scale only with the hardware, it can happen that you have already buy the biggest hardware available for you. And you can't just scale up, and then it's time to think about your infrastructure. By the way, exactly this hurt eBay in 1999. It was 20 years ago, almost 20, but now we still see this situation in many companies. So it is important not to scale up, not only to scale up, but to scale out. I want your application to be ready for capacity. So let's take a look how can we scale. Let's go through a little bit theoretical aspects of scaling. So there is a 3 axes of scale. It's horizontal scale, vertical scale, and z-axis scale. Horizontal scale, and it is duplication. When you duplicate, for example, front services behind load balancer. Vertical scale is quite different when you split your application by resources or by objects. And you can scale part of your application separately. It can be quite convenient because when your application is hosted, for example, on one server, and one server you have a database, your code base, your background workers, your cache storage, your file system and static storage. You can guarantee that when you need to increase file system, for example, for static storage, it wouldn't be used, for example, for a database. So you can not reach your goal, but if parts of your application are separated on its different hardware, you are able to scale it independently. By the way, we have a hidden benefit here. Because you can just replace a part of your application with a different language, different operation system, different paradigm of processing. And z-axis scaling, it's about sharding. It's about splitting your data by any case. For example, you have an online sales store, a platform for online sales, and then you think you have a lot of small shops working with your application, and then one of your application starts sale much more than others, and I think it is convenient to split hardware that's required for this one online store and allow it to use its own resources. But what prevents us from scaling? I think you can scale on y-axis and x-axis when parts of your application are at the same hardware. For example, you can't just set up the second instance of front server behind load balancer while your database is on the same server. So for splitting efficiently, you should put away your database on its own hardware, and then you will be able to scale horizontally. Also, it is not only about database, it is about cache storage, background workers, file system, static content, and so on. So the key is separation. And there is another one point. You can't just, your application should be ready to be, your instance of your application should be ready to scale down, so you don't have to have state between requests, state between background workers, state between requests and background workers. For example, if you are uploading a big file and then you process it with background worker, you should think of it and consider to store your temporary content somewhere away away from instance where it is placed. And also, I want your application to be ready for failure, because failure is unavoidable part of our life. We are all developers, and everybody has bugs in their code, but there is things that are not made by us. For example, server data center can be distracted somehow. You can have a connection between, can have problems with connection between servers. It's not about, it is not always about developers' fault, but it's developers. It is developers who can do it better and can prepare your application to be ready. There are several steps. Let's start from monitoring. You should use monitoring for your AP calls, for your hardware state, for example, CPU or memory usage. You should use monitoring to see the backup status. Monitoring can show you bottlenecks on your application. Let's assume that your client experienced troubles with your application. He asks support team for help. Support team tells business owners about the trouble. Business owners calls your boss, and you are drinking third beer on the after party. I think it is not cool. And monitoring tools can help you to avoid this case. You should use monitoring for everything. So if there is something you can count on your application, it is good habit to be able to visualize it somewhere. There is another good practice is log aggregation. When we are talking about horizontal scaling, for example, you need to be able to see your logs, your current state of logs somewhere. And when I say somewhere, it is somewhere away from your application, because when you have, for example, 3 or 4 instances of front workers, you see, you just cannot predict which server will proceed the request from client. A log aggregation helps you to helps you with troubleshooting. Guys, who has log aggregation? Who doesn't store log on your server? Oh, really? Okay. There is another good practice called distributed tracing. It is helpful when we are talking about microservices, and then when your request from your client can affect several parts of your application. To be able to read your logs, to be able to understand what's going on within this particular request, you can assign some kind of identification number to your request and take it with every part is inside of the process of the request. So when you will look in your logs, you will see, hey, this request was preceded by front server, then it creates a background job, and then it was preceded by another backend server, and then the response goes back to the client. There is another good habit is exception tracking. It can be okay when you doesn't use cool tools for exception tracking. It can be okay if you use email notification, for example, for your email tracking. Who uses GEM exception notification? Okay, so guys, it is okay, but it is okay only unless you have a lot of users per day, per period. Because if you failed, if there is a bug in your code, you just be flooded by your emails, and exception can be general, so it can affect every person. I think the same is relevant for Slack notification or something. So there are good tools that helps you to aggregate information about your exception. For example, you can go there and see, oh, hey, this exception affects 1,000 users, and you see it happened every 10 seconds, and it is relevant and useful information for troubleshooting. I want you to be able not just only to solve your problems, solve problems with the code, with your infrastructure, but to learn from every your failure. Discuss problems and solutions with your teammates, with your team leader, with your junior developers, because it is always about sharing information. If you just fix your problem, it can affect your application next time, and you are not be there. So another guy can spend much more time just to dig to the problem. And of course, it is useful to share knowledge inside your command. Who has kind of meetups in your company where you can have a talk and share something you have discovered or created recently? Oh, excellent. And a little bit about QA. Who has QA somewhere? Who has QA team or a QA guy, or you are just backend and QA in one person? Who has QA in your process? So I want to tell you that QA doesn't increase quality of your application. QA only decrease risks. It is you developers who can increase the quality of your application, not QA team. QA team helps you to minimize risks and helps to track repetitive problems. What about backups? Guys, who checked your backups for last month, for example? Oh, really? What about the others? Guys, are you sure that your backup is, that your database or static or something else is backed? Are you really sure? I've seen several times that instead of backup, there was a ticket and in ticket tracker that says, oh yeah, we need to set up backups. So go and check your backups. About deployment, a little. I think everybody must set up deployment process to be ready to roll back. In every moment. It is better when it is set up automatically. So, for example, you have some metrics from your application that says, oh yeah, something went wrong after my deploy, so let's roll back. Use partial deploy when you deploy your code only on several percents of your hardware or of your users. And then you can see there's something that you didn't see on a QA stage or on a development stage. For example, there can be requests that performs much more time than when you practiced on your development database. So your code can behave differently on production, so be ready for it. About autoscaling, let's go through steps that are necessary when you are setting up your autoscaling process. First of all, autoscaling helps you to save money and give you confidence in your production stability. Monitoring, again. Monitoring is the key feature of autoscaling. It is unavoidable part because without monitoring, you can't just know what is the right time to scale up or to scale down. So the first thing you should do is monitoring. Also, it is useful to have dashboards when you can see something that you can't see in your monitoring. Dashboards are always the next step. By the way, dashboards can be useful while you are setting up your autoscaling, when you configure your metrics, when you are trying to find when is the best time to scale up or to scale down. So okay. And do not forget to scale down because it helps you to avoid money loss, and you should empty your resources when you don't need it anymore. What about single points of failure? I think we should minimize single points of failure, but it is not always easy. For example, database can be a single point of failure because replication master is hard to set up and hard to proceed to deal with conflicts. But there are good practices as a master-slave with a hot switching. Also, load balancer often kind of single points of failure. I think single points of failure, when we are talking about single points of failure, we should minimize business logic and on the part that is responsible for it. For example, when we are talking about load balancer should do only balancing, nothing else. So it must be as easy as it possible to minimize effects of bugs, of code, of everything. I want your application to evolve in a natural way. For example, to set up your autoscaling process, you can't just avoid monitoring because you don't know where to scale up or where to scale down. You can't avoid dashboards with information about your servers because it's only a place where you can see if you set up your auto-scaling process properly. When you are moving towards auto-scaling step by step, it is really easy. And I think it can be much cheaper than use hardware that can't scale. You can be the cool guy who prepare your company for capacity and the same cool guy who saves a lot of money. Let's get back to requests. I think we have looked through interaction patterns. It was synchronous, asynchronous, lots of subclasses of asynchronous requests, but I think we forget about one more. It is one-way messages. What does it mean? It means that your application must do its main goal even without internet. For example, you are Twitter. You must create tweets, you must create likes, you must create shares. That's okay if there is no internet connection on your web page right now. You just can't send your request later. I think it's really cool when your application doesn't scream at user, oh yeah, no internet connection, what should we do? And then just sit quietly and wait for internet connection to be back again. So I hope all our application in some time will become much more stable and much more user-friendly in perspective of stability. I want to wish you to be competent. Learn every lesson. Have a takeout from every failure that you had in your past. Read a lot of books, talk to each other, talk to the conference. Criticize idea, argue idea, and think about solutions. It helps you to be happy. So, thank you.